Grade 12, I'm making this video to supplement our study on addition reactions. So remember, addition reactions are a situation where you have a compound with a double bond or a triple bond. Typically, we'll be looking at a double bond in the molecule somewhere, and you're going to be adding some material to it. Now, when an addition reaction occurs, you would have seen in the slides that the double bond opens up and we add something in, but I've brought in our model kit to show you maybe a bit better how this is happening. So when an addition reaction occurs, this double bond is under attack, and in our example here we have bromine, which remember would be 2 bromine atoms. What it does is, we won't get into the specifics of it, but it attacks this double bond and specifically opens up the double bond. Now, the moment the double bond opens up, you'll notice that this carbon and this carbon no longer are bonded to the maximum number of other atoms. You have to remember we have hydrogens on all these others. I just have been lazy and not added them in. So this one, remember, would not have an atom on it at this point. So when the bromine attacks that double bond and opens it up, one of the bromine atoms goes here to the open bonding site on one of the carbon atoms. Sorry, doing this one-handed, bear with me. And one of the bromines fills the bonding site on the other carbon atom. So in this case, you would end up making a new molecule. It's butane now, because you've opened up and attacked that double bond, and you now have a bromine on one of those carbons from the double bond and a bromine on the other. So in other words, you have 2,3-dibromobutane. I'm going to go through a couple other quick examples next, using the same butene molecule, 2-butene, but we're going to do the other materials we can add to it as well. The second scenario we would look at would be the addition of hydrogen. And hydrogen atoms are white in these model kits, very much like bromine. It's a diatomic molecule, so just 2. Much the same, it's going to attack the double bond. It'll open up one of those bonds in the double bond, and it will add a hydrogen to each of those carbon atoms that were in the double bond. I just want to clarify again, I'm being lazy and I don't even know that I have enough hydrogens to fill up all the surrounding carbon bonds, but you know what, I think what I'll do is splice in a video next with all of the hydrogens on here, so you'll see in the next half that it'll be all complete. Anyway, what this does, opens up that double bond, adds hydrogen in, so you've gone from 2-butene, and now, again, I'm just only going to show the points where we've added in those 2 hydrogens. You've got butane, because you just have a 4-carbon chain, all hydrogens around it. Okay, so we'll move on to our next scenario. So as promised, I've put in all the hydrogen atoms to fill up the bonds. You can see our double bond. The third scenario we're looking at is adding an acid, hydrogen halide. So in this case, it's hydrochloric acid. It, much like the other molecules we looked at, will attack this double bond. It'll open it up, and you'll have a hydrogen fill one of those bonding sites, and the chlorine, or the halogen, fill the other bonding site. So now you have a molecule, no double bond, all bonds filled. In this case, it's not a diatomic molecule with the same atoms in it. It's a H and a Cl being added in. So in this case, we again are down to butane, and at one of the bonds we now have a chlorine, and at the other we have a hydrogen added in. So this would be 2-chlorobutane. And the last one we're going to look at, same butene molecule, we're starting with 2-butene, but this time we're adding water to it. Now, this is a particular reaction that's tough to actually achieve without the proper stimulus, but we'll assume we have it for demonstration purposes. Now, I'm showing our model of water, which looks a little different than the way we typically would see it written. Remember, you have your oxygen and 2 hydrogens in that bent configuration. If you look at it this way, sometimes it's a little nicer to imagine the addition reaction. So same thing's going to happen. We're going to open up the double bond. And one of the hydrogens is going to fill one of the bonding positions, and then the remaining OH group is going to fill the other. Sorry. This is a two-hand one. So you have this new type of molecule that we haven't really talked about before, and it's what you're going to be moving on to next. It has this OH group, this OH functional group attached to it. So when we draw our final molecule, it's going to look something like this. And this is an alcohol, the other hydrogen right there. This is an alcohol, specifically 2-butanol. So you'll learn more about that naming in the next set of slides. So this again was just ultimately to supplement our addition reaction using the model kit, hopefully to better see how the double bond opens up new bonding sites through addition reactions.